Hello, this is Year 12 Further Maths, Exercise 5A.2, and I would suggest anyone who hasn't watched yet Exercise 5A.1 do so before you watch this video, because basically we use the skills we learnt in Exercise 5A.1 to be able to carry out hypothesis tests in this video. So this is Mr. Pearson. Mr. Pearson was a very famous mathematician, and it still is, because he's done a lot of work with statistical analysis. So this is Pearson. I should know his first name, but I don't, I'm afraid. But we are going to use some of what he produced. And the mere fact he's got a photo should give you a clue that it's relatively recent that he's done a lot of his work. Anyway, these are the formulae that we saw last time. We saw that you can calculate R, the correlation coefficient, using this SXY divided by the square root of SXX SYY. And of course, I've got these three separate formulas for those things. Now, when we do the hypothesis testing, what we're basically going to say is we're going to assume that a set of data has no correlation. And the alternative to that is that there is some correlation. So notice here, I've said the hypotheses for these tests for the population correlation coefficient should be, now this is a Greek letter. This is a Greek letter which we call rho. And I suppose rho you should think of as the population correlation statistic. It basically, if I was to, I don't know, if I was looking at the heights of 14-year-old boys compared to the weights of 14-year-old boys, and I might be plotting this on a graph, I might be drawing heights across here, and I might be plotting their weights up the side. Now, in reality, I'm not going to be able to go and measure the heights and weights of every single 14-year-old boy in the country. It's just, it'd take me too long. So what I do instead is I go and get a sample. And so we end up with two things. We get a sample correlation coefficient. We usually call this the product moment correlation coefficient, and it's got a symbol of R. But what it is trying to approximate is what we call the population PMCC, product moment correlation coefficient, and that is given this Greek letter rho. So notice here, when we say the null and the alternative hypothesis, I've just realized that should say a 1. When we say the null and alternate hypothesis, we have rho equals to 0, where rho is the population correlation coefficient, and the alternative, well, it might say rho equals is greater than 0. It might say rho is less than 0, or as this one I've written down here, rho is not equal to 0. So let's have a look at a few of those. Bear in mind also that we've got these rules which govern whether or not we reject or do not reject H0. Now, when we do this, we get a value for R, and we basically have to look up in tables, statistical tables that they get given to us in the exam, critical values to determine whether or not we're going to reject or not reject H0. And that's fairly straightforward. We can easily look it up in a table. I suppose the only thing I would say is there are two versions of it, and one's called Spearman's rank, and we don't want those for this one, and the other one's called Pearson's product moment correlation coefficient, so you've got to make sure you use the right one. There's also this other way of doing it, and they're called p-values. And so a question might say, here's a p-value instead. Let's just have a look at the two rules. Now, number one, if they give us the R value, or we calculate the R value, then if it's less than the critical value, then we do not reject H0. Basically, we want a strong correlation. And if it's not strong enough, then we're going to reject the critical value, reject H0. If R is greater than the critical value, then we are allowed to reject H0. Notice it's the opposite way round, though, if they give us what are called these p-values. You can think of p-values, by the way, as the probabilities of the event occurring that has just occurred. And a bit like when we've seen other types of hypotheses tests, the p-values, or in this case the probabilities, need to be smaller than the significance level. And if they are, then we reject H0. But if it's bigger, then we do not reject H0. So just notice the order of these is different in these two different versions. So that's important, that you suss the difference between p-values and R values Now, I've got a couple of examples for this. So if the p-value is 0.0828, so this is like a probability, remember. So we're saying there's an 8% chance of it happening on a one-tailed 10% significance level hypothesis test. So if I was doing this, I'd be writing the p-value is 0.0828, but 0.0828, I'm just thinking to myself, is less than 10%. So when it's less than, the p-value is less than the significance level, we're allowed to reject H0. So that's what we would do on that question. We would reject H0 because it's less than. What's it say then? If the same test was actually meant to have been a two-tailed test. All right, this is knowledge about what p-values are. Now, you can think of this as being one or two tail. If it is one tail, you might, for instance, get in this case a p-value. A p might be equal to, I'm going to make this up, I'm going to say 0.2. Notice if it's two-tail, the same test might have been mistakenly written down as a two-tail test by mistake. And if that was the case, the p-value would have been doubled. You double your p-value if you have two tails. And likewise, if they tell you two tails and you only wanted one, then you'd half it. So what's it say? If the same test was actually meant to have been a two-tailed test, what would the p-value have been? And what should the conclusion have been? Well, look, first of all, P would have to be, well, it's going to be, because it was one tail and it's now two tail. So you can see I'm doing the same as it says here. I'm going to have to double this. So I'm just going to double it. So I'm going to do 2 times the 0.0828 and I get 0.1656. Should have been able to do that in my head. Now again, this is now greater than 10%. And because it's greater than 10%, when the p-value is greater than 10%, the significance level do not reject. So I'm going to say do not reject H0. And I've got R on this question B. If R equals 0.765, now right, so we're now onto this table, this box here. And the critical value is 0.912. All right, so I'm here able to say 0.765 is less than 0.912. Now, on critical values, if it's less than, it says do not reject H0. So this is what you need to do. So you need to get your head around the different versions of these tests. So is it an H hypothesis which requires R, or is it a hypothesis requires the p-values? So on that basis, what's it say? Reject H0, yep. Do not reject H0, and then do not reject H0. So at least I agree with my 3 answers from before. So here's an example. Phoebe is looking for evidence that the numbers of cod and I should have said of tuna in the sea are negatively correlated. She observes 11 pairs of values taken from various seas around the world and summarizes her results as follows. Find the Pearson's product moment correlation coefficient. So first of all, I need to find that. So to do that, you will recall I have to do this, and this is the formula I'm just writing out now. And that implies then I need to find these 3 things. So I'm going to find SXY, that is sigma XY minus sigma X sigma Y over N. And in this case, well, I'm going to assume that's X. I'm not going to bother too much with the letters. That's going to be my Y then. And that's my XY. So I'm not going to worry too much that they've changed the letters on me. So sigma XY, that's this one here, 1184 minus 165 times by 81 over how many N was there? She observes 11. So I'm just going to type those in. 1184 minus 165 times 81 divided by 11. Minus 31 is an exact answer. It's almost a surprise. So SXX, what's that give me? Well, I'm not going to write the form for that. I'll just do it. It's the that one there, 2585 minus the 165 squared divided by n, which is 11 again. So 2585 minus 165 squared divided by 11. That's a nice answer again, and we were surprised. And then SYY, that's that one, 757 minus 81 squared over 11. 757 minus 81 squared divided by 11. That's not quite so nice. That's 160.545. So if I chuck these in, I get r is equal to minus 31 divided by the square root of 110 times that 160.545. What do I get when I do that? Negative 31 divided by the square root of, what was it, 110 times by that 160 odd. And I get an answer of minus 0.233. So that's my first job. I had to find the R value, and that's going to be the same for you in your test. I'm not sure if it comes up with that. Yes, it does. So next thing I have to do is to find what the hypothesis test is, and I have to do the hypothesis test. So now we need to do the hypothesis test side of things. So I'm going to start off, I'm going to write H0, and this is what you'll need to do. Rho equals 0. The first one, H0, is always rho equals 0. The second one, now Phoebe suggested it was negatively correlated, so we're going to say rho is less than 0. And technically we should write where rho is the population product moment correlation coefficient, something like that. Now, what did we get? We got this. We need to look up the critical value. Now, this is the table that you'll get in your formula book. It's actually a reduced part of it. But we had n equals 11. Remember that. And it also said 5%, and she thought it was one tail. So 5%, one tail, n is 11. That's the value I get there. So the critical value is 0.5214. Now, I suppose because it was a negative correlation, technically the critical value is minus 0.5214, but I never always bother with that. I would suggest you just ignore negatives. Ignore negative values. That says negatives on this. So by that I mean this value up here, I'm going to say 0.233, ignoring the minus totally, is less than 0.5214. And because it's less than 0.14, we haven't got enough information to reject H0. So I'm going to say do not reject H0. Now there's going to be a wordy bit, and the wordy bit was about Phoebe. So I'm going to write insufficient evidence that Phoebe was correct. Now I could go into talking about the tuna or stuff, but I'm just going to leave it as Phoebe is correct. That's just about enough context. I might want to do it if I was in the exam, talk about the cod and tuna stocks. Let's see what my answers say. All I just wrote was do not reject H0, which of course I did write. Now also I did there write the critical value of 0.5214. So that's been done correctly. Now, we haven't got much time left, but just bear in mind, we can just do these in our calculator as well. So for part A, I'm going to just put these into my calculator. Now, in class, I'm also going to highlight the fact that you can do this on the Texas TI-84 Plus calculator, if you've got one. If you haven't, obviously you can't. But the Texas and possibly other calculators as well, but I've never found another one that's done it. It gives me, if you know how to do it, the p-value. So in class I want to show you how to get the p-value. Obviously you can type these in and get a value for r, and you can use the formula for these and get a value for r. And in both cases we can then use the hypothesis test to test them. It's going to be all the same in terms of this one says test for positive correlation. So I suppose in both of these it's going to say H0 rho is equal to 0. And then because it said positive, I'm going to say H1 rho is greater than 0. That's a rho. It looks like a curly P, I suppose, where rho is the population correlation coefficient. So that will do for now. In class, then we'll do these two examples. It's always nice to have a couple of examples left. and then we will do, once we've done those, we will do this exercise 5A.2. So all the best, and good luck.